Hello, my name is Josh and welcome to my presentation. So today I'll be talking about my contribution to the group report, although I have helped with the graphings in the previous parts, but my main focus is the Markowitz practicality and the recommendations for the overall theory. And for the investor utility, which is my individual part, I will present my findings, my calculations, as well as two interesting recommendations conducted from my research, which is a way to improve how we calculate utility and also a way to calculate the risk aversion. So that's my name and my student ID. So firstly, my argument with Markowitz for my focus is that the way that the returns are calculated is actually based on systematic risk, and the correlation is actually only between the assets instead of correlation between the assets and the economic factors such as the interest rates. My overall recommendation is that the MVP is better. Why is that? Because when we calculate the optimal portfolio, the returns are actually calculated from systematic risk, and we know that over the COVID-19 period, a lot of fluctuations and volatility is due to the systematic risk rather than the idiosyncratic risk. So if we use the optimal portfolio to create a portfolio, the results may be very, very far off from what we expect. So for example, I've taken the log daily return graph here from the lecture just to show you, like during the COVID-19 period, the volatility is actually very high. So if you take these as the expected returns, we might not see these kind of returns during a normal period. So that's why I find that it is not accurate to use an optimal portfolio. However, if you use the minimum variance portfolio, it does work because you're actually getting a very low. You're getting all the assets with the lowest volatility together, and you create something that is almost bulletproof in terms of volatility. So if you get a set of portfolios that have the minimum variance during a period of the highest volatility, chances are you have a very, very good portfolio on the normal economic state of the world. So that's my argument against Markowitz in the report. Now, coming back to the investor utility, I'll explain why I have time in the middle here in just a second with my two findings. But first, I will present to you my results from the portfolio using risk aversion calculated from the average of my student ID, which is 4.375. And I calculated that the optimum portfolio using the solver equation to maximize the utility here will result me in a portfolio with 0.83% of the asset allocated to the risk-free asset and 0.16 of the or 16.7% of the total assets allocated to or capital allocated to the optimal risky assets. That's my result for the optimum utility portfolio. So my recommendations for this one, because this utility is actually calculated based on how comfortable an investor is when taking on a specific set of risk. So the purpose, as we know, is to calculate the highest utility of to find out which standard deviation actually provides the investor with the highest utility or the highest level of comfort. The problem with this is that it doesn't take into account the whole period of the investment period. So I came up with a recommendation. Just like the way we calculate holding period return, this is a way that we calculate holding period utility, which calculates your happiness or your economic utility throughout the entire holding period of your asset. So this is the model that I came up with. It's throughout the time. So let's say this 5 units here, this 5 utility unit is equivalent to like the optimum utility over here. So what we are taught actually is only the utility of when we first make the financial decision, but it doesn't take into account the level of utility changing throughout the time as well as receiving the reward. So for example, if we have a reward with a positive outcome, our utility might actually increase more than when we first invested when we're taking the risk. So utility actually takes into account not just the level of comfort you have when you're taking a certain amount of risk, but also the amount of reward when you're receiving, when you're getting rewarded for the risk that you take. So it should increase over time. However, this one here, the table that you are looking at, is only one state of the world where the reward is actually positive and you increase your utility. So this is the holding period utility. So what if you have other states of the world if your stocks do not do that well? So I came up with 3 state of the world investor time utility. So you have one state of the world here, which is the one that we saw just now, when you have a positive return and your utility increases. But then you have one where your reward actually goes down and your utility decreases. And then you have one where you're fluctuating, so it's kind of in the middle, but you still get a good reward at the end. So you calculate it based on the probability, and then you multiply them all together. Then you can get a more accurate level of utility, the desired utility, instead of basing your utility on only one point of the time period, which is the level of comfort you feel when you are taking a specific risk or standard deviation. And another way I calculated risk aversion, and another finding that I made is how to calculate risk aversion. So we know that in the formula, the higher the risk aversion, the less your utility, because based on the expected return minus the multiplication here. So this is inspired from a research I've done. So I found that an organization called this International Spine Study Group, they actually found a way to quantify risk aversion by using decision regret. So using like previous one, for example, you can start with a questionnaire for the investors based on 3 different states of the world. How would you rate your decision regret? So for example, this is very similar to the previous model that I showed you. So in the first state of the world where you have a positive outcome, it is more likely that the decision regret level will be low because he's quite happy with the positive outcome, so he regrets nothing. He's quite happy. But in the second state of the world, his regret might be higher because he made a loss. And the third state of the world with the high volatility, maybe that was uncomfortable and his regret level is 3. So taking the probability of these 3 states of the world and multiplying by each other, you get a risk aversion level of 4. And I have used this in accordance with the formula, and it does work very well. So that is my one argument against Markowitz, and my 2 recommendations on how, number 1, how to make utility better and more accurate, and number 2 is how to use risk aversion, which is much better than using the average of your student ID numbers. So thank you very much, and I hope this presentation has been fruitful.